All right, so we're on review sheet number 2. We're just going to pick random questions today. So which diagram represents a relation where each member of the domain corresponds to only one member of the range? When the x values are not repeated, what's that called? Yeah, that's called a function, and that's really what we're looking for. We're looking for which one of these is a function. Which one is a function? Yeah, that's it. Here's how you read choice C, by the way. This was a question from somebody. A1, B1, B2, C4. That's how you read it. Question 10. It's a function. It's a plug-in question. So just take a plus 1 and plug it in. Right? Next step. And here we go. Right? There we go. Next step. And then we're just going to combine like terms. And so we're going to, so look, we have a 2 plus 2a and a minus 2a. So they cross off. And then we have plus 1 minus 2 plus 1. So all these basically cross off. And at the end of the day, you're just left with, you know the deal. You're just left with a squared. So g at a plus 1 is a squared. That's it. Question number 13. Well, if the inverse of function f is function g, then what is f of g of x? What happens when you, so in other words, like g of x is the same thing as f inverse of x. That's what it's saying. If the inverse of function f is function g, then so what happens when you take the inverse and you plug it into the original? In other words, this right here then becomes f of f inverse of x. What happens? You always get the same answer. It's part of that thing I told you to memorize. You always get x. So now we're on question number 17, something that people had some trouble with. This is a two-part question worth 4 points. Find the inverse, and then use compositions to justify the results. The first thing we're going to do is part 1. We're going to find the inverse. How do you find the inverse? You just do y equals 2x plus 5. You switch x and y. Right? You subtract 5 and you try and isolate y. So we get x minus 5 equals 2y. You divide by 2 and divide by 2 so that you get x minus 5 divided by 2 equals the inverse. And I tend to write that in function notation like this. All right? And that's worth 2 points. This right here is the inverse of the original. Compositions, the other half of the equation. Here's what you do. You just have to sub them both into each other. First, we got to find out what happens when we sub the inverse into the original. Piece of cake. The inverse is x minus 5 over 2. So let's sub that into the original, and that's going to be 2 times x minus 5 over 2 plus 5. And that's a 2, by the way. And so, you know, this and this reduce, and then you get x minus 5 plus 5, and you get that, you know, equals x. So at the end of the day, f of f inverse of x equals x. And that's one of the things that we wanted. Now we got to do exactly the opposite. We got to find what happens when we sub the original into the inverse. You should get the exact same result. If you don't get the same result, you messed up. So we're going to get 2x plus 5, you know, minus 5 divided by 2. And so, you know, that cancels out to be just 2x over 2. And you just get x. And whoa, shocker, big shocker. You know, like, we get the same thing. Right? That technically is worth 2 points. For me, however, I would like for you to write the final last statement, and that's this. If f inverse with the original subbed in equals x, and the original with the inverse subbed in equals x, then they're inverses of each other. Of each other. And that right there is worth 4 points. 4 points. 1 point for doing, 2 points for doing all of this correctly, right? Technically, you'll get the 2 points for doing this, right? And if you don't think you can do this correctly, then you should just memorize this. This is worth 1 point, but you should genuinely know how to do all of that. It's not that bad. Number 11. In the words of incredibly smart students, this problem is OD, right? OD, son. OD, son. Okay, we're going to do this. We're going to do this. It's not OD. Don't worry about it. It'll be fine. Right? There you go. There's the question. So here's what we're going to do. We've got to solve this little part inside first. So find out how much g at negative 4 is. And to do that, you just have to sub into g. So we get 1/2 times 4 minus 1. That's going to be a half of what? 3. Oh, I'm sorry. We got to sub in negative 4. So negative 4 minus 1 is 5. And right, half of 5 is 2.5. And it's negative 5, so it's negative 2.5. My bad. My bad. So this is just f at negative 2.5. And all you do is just plug that into the equation. That's 2 times negative 2.5 plus 1 is what? Negative 5 plus 1 is what? Negative 4. Number 2, which one represents an onto function? Onto functions have all their y values being covered. They have no restrictions in their range. Everything works. So let's take a look at x squared, right? This one's kind of hard to look at on your calculator, but we're going to do the best that we can. Is A an onto function? No, because it's got a space right here. Cross A off. What about B? Let's check out B. Right? Let's cross this off. Let's go negative 6. Is negative 6 onto function? No way. No way. We got big space. Big space. What about C? Let's check out C, right? So square root of x. Hit the graph button. Of course not, because look, it's an arm-looking thing, and then we got a big space once again. And so that's this one. So now you've eliminated 3 choices. Is that good enough for that last choice? The last choice is a line, and when you graph that last choice, although your calculator is going to only show like this part of the picture, I'm telling you that that's a line. It will go on forever in either direction. And hence every x value, every y value, right, is going to get used. And there'll be no spaces. And so that's why it's said to be onto. Number 7. 7. Lucky number 7. We're just going to plug in. That's all you do. Negative 1 cubed is negative 1. Whoops. And negative 1 minus 3 is negative 4. What's the absolute value of negative 4? 4. Choice D. Guys, here we go. Number 6. Here's how you do this. What's the domain of f of x? In other words, like, okay, so you're looking at this, you're thinking to yourself, can x be everything? Guys, can x be everything? Yes. Let's do this. X can't be everything. Look, because it's a fraction. What do you know about the denominator of fraction? Denominator cannot equal 0. So then you're going to just try and figure out what numbers, right? What numbers make that 0? Negative and positive 7. In other words, x can be anything except negative and positive 7. That's how it works. We have some questions about what the hell this means. When you see plus and minus 7, that's the same. That's a really lazy way of saying 7, comma, negative 7. Problem number 5, square root. What do you know about square root? Stuff underneath it's got to be greater than, can't be negative. There. That's what you know about a square root. Stuff underneath's got to be greater than or equal to 0. So, let's give you a little hint for your test. Let's give you a little hint for your test. This is a separate problem, but very much related. Very much related. You see this thing right here? Right? Suppose you had the same problem, but it would look like this. Okay? The only way the problem would change is that now x plus 5 has to be greater than 0 because it's in the bottom of a fraction. You get it? And the fraction, the denominator, can never be 0 itself. So that's the only way this problem would change. And if I were you, I'd remember that today. Question 14, right? We've got to find the inverse. What do you do? Step 1. Lily. Yep, and then how do you get rid of that 3/2? Yeah, you multiply it by the reciprocal. Whoops. And the reciprocal would be 2/3. Anytime you multiply a fraction by the reciprocal, you just basically get rid of the fraction. So this and this cancel. Hold on one sec. And then you get 2/3 x equals y. And which choice is that? Yep. And that's choice C. Okay, question number 1. Which relation is not a function? You want to look for which one does not have x values that repeat. Let's take a look at number 1. Do the x values repeat? No, so that is a function. What about number 2? Oh, 2 x values that repeat, just choose that one. Question number 4. Which one does not represent a one-to-one function? One-to-one functions have to pass both the vertical and horizontal line test. So let's take a look. This passes the vertical line test. This passes the horizontal line test, so it's not choice A. Let's go down to choice B. Choice B passes the vertical line test, but it doesn't pass the horizontal line test. You see it hits twice. So this is not one-to-one, hence it's the answer. Graphs are easy. Graphs, you just, this is question number 8. You just take the function notation right here, sub that in for -4, and go find the corresponding y value. So we're going to look on our graph. At -4, the y value is 0, and so that's the answer. Here it's just a substitution problem, right? We're just going to sub in a minus b into the original equation. Whoops. Sorry about that. After you sub in the a minus b, you might want to rewrite it like this. This helps you remember that you're supposed to FOIL. And after you FOIL, you should get this. And finally, by combining like terms, these two right here, you get this. Oops, sorry about that. Made a mistake. I wrote it twice. You should get minus 2ab plus b squared minus 3. And that should be choice B. Question number 15, let's take care of the domain and range. The domain of the x values. The x values stretch from -2 to 2, and there's 2 open circles. So we could write that like this. Whoops, not -2 to 2. -2 to just straight up 2. Right? Open brackets because of that. Another way that you could write that is that you could have said something like this. Let's take a look at the y values, the range. The range stretches from 0 to 2, right? But here's the issue that we have at 0. At 0, you're finding that there are 2 open circles. So let's put down 0. Let's put down 2, right? At 2, it's a hard bracket because it's all filled in up over here. And then at 0, it's 2 open circles, so it's a soft bracket. Another way that you could write this is you could say that y is bound between 0 and 2.